Okay, so some equations that are not quadratic can be written as quadratic using substitution. So we are going to see something like this, an example. So we've dealt with rational, radical, and polynomial equations. So now we're dealing with something that looks like this, and we are going to convert it to a quadratic using substitution. So I'm going to write this out. Some equations that are not, huh? 2? 2/3 that are not quadratic. So when we have quadratic, we have the first term, it's an ax squared plus bx plus c equals 0. So we need to be able to convert this to a quadratic. So the way we could do this is we are going to change this to 5 times x to the something squared. So what would the exponent of x be to make it 2/3? It'd be 1/3, right? Then plus 11, and we want this to be x to the first power. So our x is going to be to the 1/3. Then plus 2 equals 0. So what we did is this is going to be our x and our x here. So we are going to substitute in, this is going to be, let's see, is it u? So we are going to actually write that u equals x to the 1/3. So we'll come back to that. That looks kind of funky. It should say x to the 1/3 as an exponent. Sorry if that looks kind of weird. So now we're going to write as 5u squared plus 11u plus 2 equals 0. So this is our new equation. So let's solve this. And then we'll have to plug back in the x to the 1/3. So since this is 5, we know the only thing to get 5 is 5 times 1. So this is going to be 5u, and this is 1u, or just u. So if we were to do the x box, 5 times 2 is 10 with a sum of 11. So what has a product of 10 and a sum of 11? 1 and 10. And then to get these guys, I'm going to come over here and do it like this. You do your box. So this is 5u squared, and this is 2. And then you have a 1u and a 10u. So we factor, so that's a 5u, and that's a u. And then this is 2, and this is 1. So it's 5u plus 1 times u plus 2. Okay, now we'll solve it. So we have 5u plus 1 equals 0, and u plus 2 equals 0. So then we move the 2 over to the other side, so it's u equals -2 for that one. And then subtract 1, divide by 5. So u equals -1/5. Okay, so then we need to sub back in the u equals x to the 1/3. So instead of writing u equals -1 to the 1 over 5, it's x to the 1/3 equals -1/5. So then we need to solve this. So what's the opposite of doing to the 1/3 power? Do it to the third power like that. So it's x equals 5 to the third. 5 times 5 is 25 times 5 more. It'd be -1 over 125. Okay, and then you have to do the other one. So you would do u equals -2. So we'd plug in x to the 1/3 equals -2. So then to get rid of the 1/3 power, we'd raise it to the third power. So x equals -2 to the third power is -8. But we want to check and make sure it's right. So we're going to check it. So you're going to do 5 parentheses. I'm going to put in the first answer that we got, the -1 over 125 raised to the 2/3 power plus 11. And then again, the -1 over 125 plus 2. So, because I didn't do to the 1/3, right? Raised to the 1/3 power. Okay, there we go. So that one worked. So then you want to do the same thing with the negative 8. Okay. And that also works. Okay, so that was the example 1. Okay, do you have any questions about it? It's just going to take a little while to get used to. Okay, let's go to example 2. X to the 4th minus 8x squared minus 9 equals 0. So we want this to be something squared. So what is that going to be? X squared minus 8x squared minus 9 equals 0. So we're going to sub in u for this x squared. And we'll rewrite the equation with u's. So u squared minus 8u minus 9 equals 0. Now we need a factor. So what gets us a product of negative 9 and a sum of negative 8? What do y'all think? Negative 9 and positive 1. Okay. So now set both of those equal to 0 and factor. Not factor, solve. And then sub back in x squared. So to get rid of the square root, we would square it. So x equals plus minus 3. And then square root. So x equals I plus minus. I should have wrote this out. Negative 3, positive 3, negative I, and positive I. I should have wrote that out on the other one too. All right, let's do number 3. Do you have any questions on that? Is that okay? Yeah. Okay, the next one is x squared minus 5 squared plus 3 times x squared minus 5 minus 10 equals 0. Okay, so see how it has the same thing in parentheses? This is something squared plus 3, something minus 10. So that means we are going to make our u be bx squared minus 5. So we'll rewrite the equation with u. So u squared plus 3u minus 10 equals 0. Okay, so we need to factor it. So what gives us a product of negative 10 and a sum of 3? Product of negative 10 and a sum of 3. What is it? 5 and negative 2. So plus 5 minus 2 equals 0. Set them equal to 0 and solve. Then you're going to sub back in the x squared minus 5 for u. So solve it out. So plus 5 to both sides. X squared equals 0. Take the square root. So x equals 0. Plus 5. X equals 7. X squared equals 7. Then take the square root. So x equals plus minus square root of 7. So we can write it as negative square root of 7, 0, square root of 7. Okay, y'all got the hang of this one? It's not too bad once you see it a couple of times. All right, so let's do absolute value equations now. So we're solving all kinds of equations. So remember with absolute value equations, anytime you have an absolute value of anything, it's always positive. It describes the distance x from 0 on a number line. When we solve absolute value equations, what's inside here could be positive or it could be negative. Because our outcome is always positive. But x could be positive or it could be negative. So we are going to rewrite absolute value equations into two equations like this. The absolute value of u equals c means we can write the two equations. U equals c and u equals negative c. I believe you have done this before, right? Do you remember doing this in Algebra 2? Vaguely. So if we have the example 2x minus 3, the absolute value of 2x minus 3 equals 11. Then we would write this as two different equations. We'd write it as 2x minus 3 equals 11, and 2x minus 3 equals negative 11. And you'd solve it to get the solutions. So you would add 3 to both sides. So 2x equals 14. Divide by 2, x equals 7. And then you could solve the other equation, add 3 again. But this time negative 11 and a positive 3 is negative 8. Oh, why did I do that? That should be gone. Then divide by 2. So x equals negative 4. So no matter if you put in negative 4 or positive 7, it'll come out to 11 or negative 11 inside here, which if you take the absolute value, you get a positive 11. So you would check each solution by plugging it in. We're just going to do it in our head. 2 times 7 is 14. 14 minus 3 is 11. Absolute value of 11 is 11. The next one, negative 4. 2 times negative 4 is negative 8. Negative 8 minus 3 is negative 11. But you take the absolute value and you get a positive 11. Okay, let's look at another example. 5, absolute value of 1 minus 4x minus 15 equals 0. So in order to solve this, you've got to isolate that absolute value. So the first thing you want to do is get rid of this minus 15 by doing plus 15. And then you divide by 5. You get 1 minus 4x. Absolute value of that equals 3. And then we would set them equal to the positive 3 and negative 3. So 1 minus 4x equals positive 3, and 1 minus 4x equals negative 3. So we solve it out. Two over negative 4 is negative half. And then the other one, minus 1, negative 4x, negative 4, divided by negative 4, x equals positive 1. So either answer will work. Make sure you plug it in to check it. Yeah, we're almost done. Okay, the only time you would have a no solution is if you have, let's say, absolute value of 4x minus 3 equals negative 2. That can never happen because you're taking the absolute value, and it'll always equal positive. So this would be no solution. There's nothing that'll make this work. And that is it for your notes for today.
Where's our Chromebook again?